Hi students, welcome back to MathsGenii. Please watch the part 1 of the video if you have not watched it already. In this video, we're going to cover slope of tangent and normal, local maxima and minima, and also absolute maxima and minima. So let's get started. So here, if you can see on the screen, I've written for tangent and for normal. So we are going to interconnect. So let's just see what normal and what tangent means. So this is a curve and a line which passes through the curve touching at one point of the curve is the tangent and the line perpendicular is the normal line. In the lower standards, you have already studied this equation. Y minus y naught is equal to mx minus x naught. What is m? In the lower standards, you've already studied this. M is nothing but the slope. M is nothing but the slope of the line. Okay. But then we are dealing with application of derivatives, and we have also studied in derivatives that the slope is given by dy upon dx. So that is what we have studied. So I'm going to rewrite the same equation. This is the equation that you've studied in 11th grade. I'm rewriting the same equation. Y minus y naught is equal to x minus x naught. And in place of m, what are we going to write in this chapter? Dy by dx. So this is how the equation for tangent looks like. Similarly, now you observe that this normal is perpendicular. So when the slopes are perpendicular, in lower standard you have studied this concept in lines, that when something is perpendicular, the other slope is minus 1 upon m. So the perpendicular line's slope is minus 1 upon m. So in this case, our m is dy by dx. So what is the equation for slope of normal? I'm just rewriting the same equation. And there is only one change, which is the slope will become minus 1 upon dy by dx. That's it. For the entire concept of tangent and normal, these are the only two formula you need to know. Equation of tangent and equation of normal. I think it's pretty clear. Okay. Now, what are the type of questions that you might get asked in this tangent and normal concept? First, they can ask you, "Key, tell me, find the slope." So, if whenever they're asking you to find the slope, you will first find dy by dx, right? Slope is nothing but dy by dx. For tangent, we saw the slope is dy by dx, and for for normal, the slope was just minus 1 upon whatever the answer you will get for this, correct? Minus 1 upon f dash of x. Okay, another type of question that they might ask you in this chapter is find the equation of tangent and normal. And the third type of question that is asked in this chapter is find the points on the curve. We are going to look at example of each of these questions. Okay, let's start with the first. What is the first type? Find the slope. Okay, so in the question, they are asking you find the slope of tangent, and the curve is also given. This is your curve, correct? Now they're asking you to find the slope. Slope is nothing but dy by dx, correct? So you have dy by dx. What is the derivative of x cube? 3x square minus, what is the derivative of x? It's 1. He has also mentioned the point in the question, x is equal to 2. So I'm just writing x is equal to 2. So wherever you have x, just substitute 2. So 3 4s are 12, 12 minus 1, 11. Very simple. Okay, this is the slope for tangent. If he would have asked you slope for normal, it's not asked in the question, but I'm still showing for your information. Slope of normal would have been minus 1 upon slope of tangent. This is slope of normal, and this is the answer for slope of tangent. So the first type we have already covered. What was the second type? Find the equation of tangent and normal. So we have already seen two formula. This is equation of tangent, this is equation of normal. So this is what we are going to apply. Okay. Find, let's take another example first. Okay. Find the equation of tangent to the curve at the point where it cuts the x-axis. So it is asking you find the equation of tangent. So remember, we want to use that formula. What was that formula? It was y minus y naught is equal to dy by dx x minus x naught. So this was the formula for equation of tangents, correct? Now, where is y naught and x naught given in the question? X naught and y naught is not given in the question. But how will you find it? It's there in the question but not given directly. Now carefully look at the statement in the question. I'll just highlight it. Find the equation at what point where it cuts the x-axis. So when something cuts the x-axis, y becomes 0. When something cuts only x-axis, if I have a line which is cutting only x-axis, is the y coming in picture? No. So y is always 0 when the line cuts the x-axis. So since it cuts the x-axis, y becomes 0. So substitute y in the substitute y is equal to 0 in this question. So I'm just substituting y as 0. So you have x minus 7, x minus 2, x minus 3. This entire term goes this side. Multiply with 0, it will become 0 itself. And then you have this minus x goes that minus 7 goes that side, becomes plus 7. So you have x is equal to 7. So you have now you have the value of what? X naught and y naught both. Now you have the value of x naught and y naught both. What is the value of x naught? 7. What is the value of y? 0. Why 0? Because it is cutting the x-axis. If he would have told me it is cutting the y-axis, then x would have been 0. Okay, so x naught and y naught, this is solved. Now one more thing I want dy by dx. So I've already calculated dy by dx here because the calculation was longer. So I preferred to paste the solution. So what I've used is, I have calculated dy by dx for this. How I've calculated? If you remember, this is of the form u upon v, correct? So what is the formula of u upon v? It's v derivative of u minus u derivative of v upon v square. So this is the formula we have applied here. When you solve this by u by v derivative rule, on simplification you will get this. Okay, now what am I going to do as my next step is, I know the values of x and y, 7 comma 0. So I'm going to substitute. So this is your answer of dy by dx. I'm going to substitute 7 comma 0 here. So in place of x you have 7, and so be careful, the minus sign is outside the bracket. So 7 square, 14 into 7 minus 29 upon 7 square plus 6 minus 5 into 7 the whole square. Okay, now when you solve this further, what will you get is minus 49 plus 98 minus 29. Then again, when you expand this bracket, you will get 20. 20 square will give you 400. Then again, when you solve this, you will get 20 upon 400. 10 gets cancelled. So 2 upon 40 will give you 1 upon 20. 2 ones are 2 twos are and 0. So 1 upon 20 is the value of dy by dx. So you already know the value of x naught, y naught. We had calculated. It was 7 comma 0. Okay. Now what is the final conclusion? Why did we do all this? Because we wanted to find the equation of tangent. The formula is this. Let's just rewrite the formula. Equation of tangent is given by the formula y minus y naught is equal to dy by dx x minus x naught. So y minus 0, 1 upon 20, x minus 7. Correct? So you will have it as y minus 0 is nothing but y. So 20y is equal to x minus 7. So the entire equation will be this. I will bring it to this side. So x minus y minus 20y is equal to 0. So this is your equation of tangent. So first we found out the value of x naught, y naught, and then dy by dx. Just go with the formula. Okay. Now, the last type of the question that is asked. We have covered both these types. The third type is find the point on the curve. So let's look at that question also. Now, if you look at it very carefully, you have been given a y and you have also been given a slope. Okay, you've been given a slope. Now, what is the formula of slope? If you talk in general with respect to this chapter, formula, how do we find slope? We find slope by dy by dx, correct? So we have a equation given in the question. Let me just copy this equation. Minus 1. Now the derivative here is a little tricky, so be with me on how I am finding the derivative. If you want a detailed explanation, it's there in the differentiability chapter, also derivative chapter that I've uploaded. So you'll get a good idea there. Okay. Uh, for the ease of convenience, this square root, what I'm doing is I am removing the square root sign. Can I write instead of square root? Can I write raised to half? It is the same thing, right? If I write square root or I write raised to half, it is the same thing. Now I'm going to apply the derivative formula of x raised to n. The formula is what? Nx raised to n minus 1. In this case, n is half. N x raised to n minus 1 minus, what is the derivative of 1? 0, because 1 is a constant. Half 4x minus 3. Okay, one more thing that we are forgetting here is this was not purely x. Okay, you did not have only x here. If I would have had x raised to half, then I can directly find the derivative. But you have something here that I have considered as x. So with chain rule, you have to write d by dx of 4x minus 3 minus, what is the derivative of 1? It's 0. Always, if you don't have x here, then whatever you have, you will have to take the derivative and multiplication. This is explained in details in my derivative video, so you can always refer that. Half minus 1 is minus half into derivative of 4 is a constant. Derivative of x is what? 1 minus 3. Derivative of 3 is 0 again, so I'm not writing. Again, something can be cancelled. 2 ones are 2 twos are. So you have the final output as 2 upon, because this is minus half. Half means square root. and because it is minus, hence it is going in denominator. So now you got your slope finally, but they have also given one slope in the question. They have given slope as 2 by 3. So can I compare both these slopes? Of course I can compare. Okay, so now this 2 and this 2 gets cancelled. Then if you cross multiply, you will have something like this, because this is going to be 1, this is going to be 1. So 1 into 4x minus 3, 1 into 3, same number itself. Then square root sign goes that side, becomes square. 4x is equal to 12, x is equal to 3. You got x. Now you want to find y. So substitute in the question. I'm rewriting the question. The question was y is equal to 4x minus 3 minus 1. I have gotten the value of x. So in place of x, I am replacing it with the value that I got. Okay, so you have something called 12 minus 3, which is 9. So you have 3 minus 1, which is 2. So you have y 2. So what are the points required? The points required are x comma y. So x is what? 3 and y is what? 2. So 3 comma 2. So we have covered all the questions that probably are asked in such chapters. If you want, we can cover one more of such type before going ahead, where it is also asking you the equation of tangent as well as normal. Okay, so we already, and the points are given this time, so x naught and y naught are given, you don't have to separately find it, so that's a relief. So according to the formula of equation of tangent, you want y naught, you know, you want x naught, it is already there. What you don't have is dy by dx, so we can easily find dy by dx. So this is your question, and now I'm going to find dy by dx. So x raised to n formula, n x raised to n minus 1. So 2 minus 3 minus 1, minus 1 by 3, plus again in place of x you have y. Okay, so first I will calculate it in the same way as I've calculated this, but here you don't have x, here you have y, so you will have to write dy by dx. Then what is the derivative to 0? Then what I want to find dy by dx, so I will isolate it. Okay, this will go that side, become minus. This is in multiplication, will go this side, will come in division. Now I can cancel this 2 by 3, 2 by 3 common, and I can also say that minus sign x upon y, and both these powers I'm just taking a common power. So you got dy by dx. You have the values of x and y in the question, 1 comma 1. X is also 1 and y is also 1. Let me just substitute. So 1 upon 1 is nothing but 1. Anything raised to 1. Anything raised to 1 gives you 1 itself. Here you have a minus sign outside, so you will have 1. 1 raised to 100 will also give you 1. 1 raised to 2 lakh will also give you 1. So anything raised to 1 will give you 1 only, but you have a minus sign here, don't forget. Now you got dy by dx. Now I can find the equation of tangent. What is the equation of tangent? It's y minus y naught dy by dx x minus x naught. Or in place of dy by dx, you can also write f dash of x. Both are correct. Okay. So y minus y naught is 1, x naught is also 1, and you got dy by dx as minus 1. Correct. So what you have when you rearrange all this, I'm bringing x this side, y this side, and then this will become -2. So this is the equation of tangent. What is the formula for equation of normal? Y minus y naught is equal to 1 minus 1 upon f dash of x minus x naught. What changes is just the slope. Okay, so we again have the same thing. Y naught is 1, x naught is 1 given in the question itself. Minus 1 upon, what is the value of f dash of x or dy by dx? -1. So let me just write -1. So both of this will get minus sign gets cancelled. 1 upon 1 is 1 only. So the equation becomes this x and this y will come on this side. This -1 will become, this -1 is already there. This -1 will come this side, will become +1. -1 plus 1 gets cancelled. So 0 is equal to x minus y is the equation of normal. So we have covered equation of normal, equation of tangent, both. Why do we need to study maxima and minima? Firstly, let's understand with two examples. So, in the first example, it says a ball thrown into the air from the building. It's thrown in the air at 60-meter height. Now, where x is the horizontal distance and hx is the height. What is the maximum height reached by the ball? So, this might not sound very useful to you, but another example might. So this is just a normal example. I'm throwing a ball up at 60-meter. Um, and what is the maximum height the ball can reach? So that is what we can calculate. But let's look at some real life example, which where we might actually be using it. So helicopter of enemy is flying along a given curve. So I've plotted this curve here. So the curve is x square plus 7. So we have plotted x square plus 7 here. Okay, how does the curve for x square looks like? This, correct? X square plus 7. So we have plotted plus 7. Okay, so this is the helicopter of the enemy. Now a soldier is placed at 1 comma 2. So 1 comma 2 somewhere here. This might be 1, this might be 2. So somewhere here. Now this soldier wants to shoot the helicopter of the enemy. Now, what is the shortest distance where, what is the nearest point where he should start shooting? Right? Wants to shoot the helicopter when it's nearest to him. So, when will it be nearest to him? That will be given by maxima or minima. So, that is how and that is why we are going to study maxima and minima. There are two terms that you're going to find very confusing in the chapter: local and absolute. It's very simple. Why do I say it's very simple? For example, um, in your school, when you had inter school contests, uh, there were, so in a class of say grade 10th, you had four division A, B, C, D, and from the division A, someone won the race. Okay, so from A, the person who won the race is the local maxima, and the one who came last in the race is local minima. Similarly, from B, the one who came last in the race is local minima for B, and local maxima for B is the winner. So, for each division individually, we have local minima and maxima. But what is absolute maxima or minima? The one who is winner of all is the maxima, and one who came last from all these division is the absolute minima. So local is for individual divisions and absolute is the winner of the entire school contest. Okay, so I hope this small example made it absolutely clear. So now there are ways to find local maxima and minima. So always you cannot use a graph. So I'm first going to explain with the graph. Okay. Now, let's look at the graph first. Ignore the first sentence and just look at the graph. So consider something from A to B. The graph is increasing, but at B, the graph has stopped increasing. Correct? Now it has started decreasing. So B is the point where it has reached the maximum. Correct? Now it cannot reach further maximum. This is the maximum, highest value. So this is local maxima. Okay? Now from B it is decreasing, 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 decreasing. C till C. Now again it has started increasing. So from B to C it is decreasing. This is the lowest value, correct? So this is local minima. Again, now check out C to D. It's increasing, increasing, increasing till this point. So this point is your local maxima. Okay, super clear. Now let's look at the concept part of it. Every monotonic function or every smooth function assumes its maximum or minimum value at the end points. Correct? So this was an end point, this was end point. So maximum or minimum value is attained at the end point of the graph. But always you cannot have a graph. You will have difficult equations, x raised to 5 plus 7x plus 8, 9x square, or whatever. You will have long equations, and plotting graph will take the time away and you will just be able to solve one question. Correct? So hence we use derivative. Okay, now the question is what to do. Why we use derivative test for finding maxima and minima is the question. Okay, now I'll explain you why we do that. Again, the same sentence that we saw, maximum minimum value are found at the end points for a smooth changing function. We had seen, right? So these were the points of maxima and minima. But why do we have to use derivative to find what is the point of local maxima and local minima? I'll tell you. What happens at the end point or flat points? What happens at the end point or the flat point? This is the slope, you agree? This is the slope, this is the slope, this line will be the slope. But at the end points, the slope is becoming zero. It's flat. You have nothing. The slope is zero. Okay. So what happens at the end points? Slope becomes zero. How to calculate? So this point I want, right? This point I want, and here the slope is zero. So I will have to find the slope. To find this point, I will have to find the slope. How to calculate slope? dy by dx. This is how you calculate the slope. When is the slope zero? At this point. So we will solve the question, and then you will understand this point. So for now, I was trying to explain why derivatives used. Okay? Because we want to find these flat points, and at flat points the slope is zero, and slope is calculated using derivatives. Okay. Now I have written a few steps on how to solve the questions. These are the steps that are common. I am sure increasing decreasing function in my previous video, if you have seen, this step and this step is the same. First you find f dash of x, then you put f dash of x as 0. Now why do you put f dash of x as 0? Here was the reason, because the slope becomes 0 at this point. So f dash of x is 0. Then you find f double dash, and then you check the answer of f double dash. If the answer is less than 0, then the point is maxima. If the point is greater than 0, then the point is minima. So we are going to see the questions, don't worry. Find the local maxima and local minima of these points. Okay, so what was my first step? My first step was find f dash x. Let's find f dash x. 3 is a constant into 4x cube plus 4 is a constant. X cube derivative is 3x square minus 12. X square derivative is 2x plus 0. 12 derivative is 0. Correct? So from this, I have 12x cube 12x square minus 24x. From all this, I'm taking 12 common, and I am also taking x common. So what will remain is, here you have x square. Sorry. So here you have x square. So I'm taking x common. So what will remain? X square. Here x, and here 2. That's it. So 12x. And when you factorize this, you will get x minus 2, x plus 2. Okay, you can factorize it. 2 ones are 2, the normal 8 standard method. Okay, so when you factorize this, you will get this as your answer. So my aim is, when is my f dash x going to be 0? For f dash x to be equal to 0, at what values? Because that is what I want to find, right? When will f dash of x be 0? So if you put x is equal to 0 in this question, in this equation, you will get f dash of x as 0, correct? But there are more values. If you put x is equal to 1, so if you put x is equal to 1, so 1 minus 1, 0. Anything into 0, everything is in multiplication, right? So even if one term becomes 0, all term becomes 0. So if I put 1 here, everything will become 0. So x is equal to 1 will also give me 0. Also, x is equal to minus 2 will also give me 0. If I put minus 2 here, minus 2 plus 2, 0. Everything into 0 is 0. So these are the three values that are going to give me 0. So that is your first step. Find f dash of x, then find points where f dash of x could become 0. Okay, these are the points. Now what did I tell you? Find the double derivative. Third step is find the double derivative. So what is the first derivative? Let's just copy the value of the first derivative. Okay, I have copied. This is your first derivative, and using this we are going to find the second derivative, f double dash. Okay, so I have something called as, let's not take the bracketed equation, let's take the entire equation into account. Okay, I'm taking this equation before putting into club bracket, because solving derivative will become easier. All the equations are same, just that we have bracketed and taken common. I'm taking the equation where we have not taken common. So x cube derivative 3x square, x square derivative 2x minus 24, x derivative is 1. Correct. Again, I can take something common here. I can take 12 as common. What remains is 3x square plus 2x minus 2. Okay. Now I had gotten three values, 0, 1 and minus 2. So I'm going to substitute 0 and then 1 and then minus 2. So this is my step where I have found double dash of x and substitute the points. So let's substitute 0 in place of x. So this is what is going to remain. I'll just solve one in elaborate, others you will understand by yourself. So 0, 0, 0, 12 into minus 2 remains. So it is minus 24. If you put 1 here, so it will be 3 plus 2, 5, 5 minus 2, 3. 12 3s are 36. If you put minus 2 here, it will be 3, 6, 12 minus 2, 72. Okay, in place of x, you have to put all these values. Now, what was the conclusion? Less than 0 or greater than 0? First, find that. Minus 24 is it is less than 0. This is greater than 0. This is greater than 0. What did I tell you if it is less than 0? If your answer of f double dash of x is less than 0, then it's maximum. So minus 24 is your maxima value. And if it is greater than 0, then that is minima. So you are getting for 0 you are getting maxima value, and for 1 and -2 you are getting minima value. Now I have to find the value. One more step. Now I have to find the value, and value I will get from the question. What was the question? This was the question. Let me just copy again. F of x is equal to 3x raised to 4 plus 4x cube minus 12x square plus 12. So at what point did you find maximum value? At point 0. So for maxima, I'm substituting x as 0. So if you put 0, 0, 0, what will remain is 12. So your maximum value is 12. Correct? At f is equal to 0, your maximum value is 12. And for the other 2 points, you got minima. So for minima, you have 2 points, which is x is equal to 1 and x is equal to -2. So for the values, I'll have to put in this equation, I'll have to put x as 1. Correct? Minus 12 square and plus 12. Okay. So if you solve all this, this is f of 1. So if you solve all this, you'll get 7. Similarly, if you put f is equal to -2 in place of x, you will get another minimum value, which is going to be -20. You can cross check. So this was the entire steps. It is lengthy, but if you do it carefully and follow these methods, one step that I missed out is substitute. We did it in the question. We substituted back in the question, right? So 1/5 step is substitute in the question for values. So these 5 steps, if you follow, you can solve any local maxima or minima question. Okay. Now find all the points of local maxima and minima. That is what it is asking me. What is the first step? F dash of x. Ignore the graph. I have put the graph for other purpose, but that I'll tell you at the end. So f dash of x I have to find. So 2 into x cube is 3x square minus 6. X square derivative is 2x plus x derivative is 1 and phi derivative is 0. So can I say that I can take 6 common? So you will have this. Then this is nothing but x minus 1 the whole square. Correct? This was your f dash of x. This is your first step. Now I have to find where the f dash of x is going to be 0. So at x is equal to 1. If you put 1 here, f dash of x will become what? 0. Correct? So this was my first step. Second step, this was my second step, f dash of x. And then I found the values also. Third step is f double dash of x. So let's find f double dash of x. 6 is constant, will remain outside. X square derivative 2x minus 2 into x derivative is 1 and 1 derivative is 0. So you have this as your answer. F double dash x also I have found. Now what we do, we substitute the point. So f double dash of 1, 6 into 2 into 1 minus 2. F double dash also you are getting 0. So second derivative test fails. second derivative test fails. So what we can say is, at x is equal to 1, at x is equal to 1, it is neither a point of local maxima nor local minima. It is in fact, it is called point of, we should not get 0 as answer, right? So second derivative failed. So this such type of question graph is called as point of inflection. So this one is a point of inflection. Now I have plotted the graph of this question. This question is represented in this graph. So you see there is no local maxima, there is no local minima. This is a point of inflection. This is 1, right? So probably this will give you a point of inflection. This is not increasing, decreasing, increasing. So it's a very mixed signal. So this is called as point of inflection. But this is such a tough graph to plot. You can't always plot the graph. That is why you have to do the second derivative test to understand that this was neither local minima nor local maxima. Okay. Now let's look at something called as absolute that we have studied. Absolute is the overall, the king. Okay. So you look at this graph. We have already seen a miniature part of this graph. So if you see, this graph is decreasing, decreasing, decreasing. So this point is the local minima. This point is in this graph from B to C. It's increasing, increasing, increasing. This point, it stops increasing. So this is local maxima. Correct? So this was all local. But what about absolute? So if you see that f of A is the highest and f of D is the lowest. If you calculate the value, f of A has the highest value and f of D has the lowest value. So f of A is absolute maxima and f of D is absolute minima. Okay. How to calculate this? There are fixed steps. You just have to follow those fixed steps and this is not, you don't have to do first derivative test or second derivative test. For local we did first and second derivative test, but for absolute you have different steps. So first it says find all the critical points. Okay, you just see this and we will solve it and you will eventually understand. Let's find f dash of x. So 2 is a constant, x cube derivative is 3x square minus 15 into x square derivative is 2x plus 36. X derivative is 1 and 1 derivative is 0. Okay, so this is 6x square minus 30x plus 36. So I'm done with the first step. Now let's go back. Take the end points of the interval. Okay, so first we will have to find the points. So let's take 6 as common, and when you factorize this you will get two factors of 5, which is 3 and 2. So you'll get x minus 2 and x minus 3. So again, the same thing that we did in local maxima minima, the first step remains the same. Find the points where f dash of x could be 0. Okay, so there are only 2 points where f dash of x could be 0, which is x is equal to 2. If I put x is equal to 2, entire thing will become 0. 2 minus 2, 0. 0 into every term will become 0. Another chance is x is equal to 3 if I put. Then everything will become 0. So these are the 2 points. Now, we shall now evaluate the value of f at these points and at the end points of the interval. Okay, so these points and at the end points. Okay, what are the endpoints given in the question? 1, 5. So we are going to evaluate at x is equal to 1, x is equal to 2, x is equal to 3, and x is equal to 5. Because 1 and 5 are the endpoints, and 2 and 3 are the points that we found out. So how do you find it out? Is by substituting. This is the question. We are going to substitute one by one. Let me just copy the question again. For step 3, f of x is equal to 2x cube minus 15x square plus 36x plus 1. So let's find f of 1. So substitute 1 in place of x. So you get 2 minus 15 plus 36 plus 1. So you get 24. Similarly, what is the next value? F of 2, f of 3, and f of 5. This is what I want to find. So in place of x, let's put 2. So we will get it as 29. In place of x, put 3. Then you will get it as 28. And in place of 5, in place of x, put 5. You'll get 56. Now what is the last step enlisted? Identify the maximum and minimum values of f out of the values calculated in step 3. This maximum value will be absolute maximum and minimum value will be absolute minimum. So what is he asking me? In the step 3, find what is maximum, what is minimum. So what was the maximum value that we obtained? 56, correct? And what was the minimum value we obtained? 24. So we can conclude that, thus we conclude that maximum value of f, absolute maximum value, is 56, occurring at what point? X is equal to 5, and absolute minimum value is what? 24, occurring at x is equal to 1. So I hope this elaborate steps and discussions helped you, and do watch part 1 and part 2 for the entire concepts of application of derivatives. Bye, see you in the next video.